This is what we have combining the first two steps. This two comes from the first step. This one comes from the second step. Okay? Okay, this comes the first step, right here. This one comes the second step, right here, and plus Q here. Okay? Then I'm taking the Z derivative on both sides. Taking the Z derivative on both sides, according to this equation, what do we have? 0 plus 2x plus 2z, I'm sorry, 2y plus Q prime of z. All right? This Q is a function depending only on z, which means if I take the derivative, I'm getting a regular derivative here. So I get a regular derivative with respect to z, and I have to make it equal to 2x plus 2y in the end. Okay, by using the condition over there. So in the third step, I know Q of z has to be equal to 0. Okay, which means Q has to be a real constant, right? Because QZ can only depend on z, and the derivative with respect to z is equal to 0. So Q has to be a constant. So QZ is equal to a real constant. So combining the three steps, I have phi of xyz is equal to xy plus 2zx coming from the first step, plus 2zy coming from the second step, and plus a constant coming from the first step. And this is a uniform way to find the potential function for any given conservative vector field. You can check, and you definitely should check. So in your test of your final, taking the derivative is easier pass, always check. X derivative, y plus 2z. Y derivative, x plus 2z. And z derivative, 2x plus 2y. It is fitting in the end. Okay? This part I acknowledge, this is probably the most mentally challenging part. Okay? So you have to figure out what it means. But the next week, we'll be going through a couple of more math to help you understand this. You have to go and try to understand yourself. That will make your job much easier coming into next week. Okay? I don't want you to come back again and still working like